In Lesson 1.7, we'll be talking about the distributive property. Our guiding questions: what two operations are involved when using the distribution property? And 2, is the distributive property commutative? By the end of this lesson, go back and see if you can answer these questions. We use the distributive property to simplify the product of a number and a sum or difference. If we look in the distributive property box here, we can see some examples of that. We take what's outside the parentheses and we multiply it by what's inside. So in the example, we have 4 times 20 plus 4 times 6. And it doesn't matter whether the number on the outside of the parentheses is in front of the parenthesis or behind it. It works the same way. So if you're thinking about that guiding question, is the distributive property commutative? Yes, it is. And if we look at the second example shows 7 times 30 minus 7 times 2. So it works for addition and it works for subtraction. In problem 1, it talks about what is the simplified form of each expression. If we look at example A, we have 3 times x plus 3 times 8, which gives us 3x plus 24. In example B, we take the negative 7 and multiply it by 5b minus the negative 7 multiplied by 4. And that gives us 35b, negative 35b plus 28. Now I would like for you to try examples 1a, b, c, and d. Now we're looking at using the multiplication property of negative 1. If we see this problem, what is the simplified form of, and we have the negative sign, and then we have parenthesis 2y minus 3x, that negative means negative 1 times 2y minus 3x. So what that means is I'm distributing the negative 1. And what happens when I distribute negative 1 is everything inside the parentheses changes sign. 2y becomes negative 2y, and minus 3x will become plus 3x. Now I'd like for you to try the guided problems 3a, b, c, and d. You should remember that a fraction bar can act as a grouping symbol. A fraction bar can act as a grouping symbol. It indicates division. It indicates division. Any fraction, a over b, can also be written as a times 1 over b. You can use this fact and the distributive property to rewrite some fractions as sum or differences. So if we look here at problem 2, rewriting fractional expressions, we ask what is the sum or difference? What sum or difference is equivalent to 7x plus 2 divided by 5? Okay, we can think of that in a couple different ways. We can think of it as meaning 1/5 times 7x plus 2, and then use our distributive property, distribute the 1/5, and we get 7/5 x plus 2/5. Or you can look at it as if we have 7x plus 2 divided by 5, we can look at that as being two different fractions. We can look at the first term, 7x, divided by 5. And then we have the plus sign. And then we would have the second term, 2 divided by 5. So you can think of it in either terms you would like. And if you can simplify either of the two fractions after you separate them, then you would need to. So why don't you try guided problems 2A, B, C, and D. Now we have a couple of vocabulary words we need to look at. It says you can simplify an algebraic expression by combining the parts of the expression that are alike. So we need to make sure we're clear on what these terms actually mean. A term is a number, a variable, or the product of a number or one or more variables. So that means a term can be a number such as 7. It can be a variable such as x, or it can be the 7 and the x multiplied together, the product of a number and either one variable such as x or more than one variable such as 7xy. All of these are terms. The constant is a term that has no variable, so it would just be a regular number. For example, 8, 6, -4. All those are constants, just numbers, no variables. The coefficient is the numerical factor of a term. So if I had the term 4x, my coefficient would be 4, the numerical part of the term, the number that is in front of the variable. Like terms have the same variable factors. If we look here at the expression, we can see that 6a squared, -5ab, 3b, and 12, -12 are all terms. If we look at those terms, we can see that the 6 is the coefficient of a squared, -5 is the coefficient of AB, 3 is the coefficient of B, and -12 is a constant term. If we look at these terms here, we can look at their variable factors, and we can then decide if they're like terms. If we look at 7a and -3a, we can see that their variable factors are indeed alike. Their variable factors are both a, so yes, they are like terms. If we look at 4x squared and 12x squared, we can see that their variable factors are both x squared. So again, they are also like terms. If we look at the next set, 6ab and -2a, we see that AB is a term and A is a term. They are not alike, so therefore they are not like terms. And if we look at the last example, we see xy squared and x squared y, again, are not the same, so they are not like terms. In problem 5, we look at combining like terms. What do? When we combine like terms, we add or subtract the coefficients. Add or subtract the coefficients of like terms. Variable parts stay the same. So if we look at this example A, we'll see that we have 8x squared and 2x squared. Same variable part, so we have x squared as our variable. Then we add the coefficients. A plus 2 would be 10. So 10x squared would be our solution. Looking at example B, I could look and see that I have 5x and then the 3x that are like terms. So reading them from left to right, I'm going to read 5x minus 3x minus 3x. So 5x minus 3x gives me 2x. Then I have the 6y term, which has nothing to combine it with. And then I have my negative 3 plus 4. Negative 3 plus 4 would be 1. So that solution would be 2x plus 6y plus 1. I would like for you now to try the Got It problems 5A, B, C, and D.